What if I told you there exists a planet 635 light-years away where a day could last forever? A world where oceans cover almost the entire surface and where life could evolve in totally unthinkable ways. Today, we're going to explore Kepler 22b, one of the most intriguing exoplanets ever discovered by humanity. This planet literally has everything it needs to become the new Earth, but its mysteries could transform it into a world beyond our wildest dreams or nightmares. We're talking about a world with gravity 6 times stronger than Earth, where a simple fall could be fatal, where unexplored oceans hide unimaginable secrets, and where bioluminescent creatures could inhabit a side of eternal darkness. Get ready to embark on a fascinating journey to one of the most enigmatic planets in our galaxy. The discovery of Kepler 22b wasn't just a scientific milestone, it was a revolution in our understanding of habitable worlds. Let's go back to the year 2011, when the Kepler Space Telescope was silently observing more than 150,000 stars simultaneously, searching for signs of planets in their orbits. The method used is fascinating in itself. Imagine you're watching a lamp in the distance, and periodically a fly passes in front of it, blocking a small amount of light. That's exactly what happens when a planet passes in front of its star. The brightness decreases slightly, creating a unique signature that scientists can detect. This method, called transit, is incredibly precise and allows us not only to discover planets, but also to determine their size, orbit, and even clues about their atmosphere. That's how we found Kepler 22b, orbiting in the habitable zone of its star, that golden region where water can exist in liquid state, neither too hot nor too cold. But this was just the beginning of our journey of discoveries about this extraordinary world. The parent star of Kepler 22b is a yellow dwarf, fascinatingly similar to our Sun. Named Kepler 22, it's approximately 4 billion years old, almost the exact same age as our Sun. In size and composition, the similarities are impressive, but there's a crucial difference. It's about 20% dimmer than the Sun, which means that even with powerful telescopes, it remains invisible to the naked eye from Earth. This difference in the star's luminosity creates the first great mystery of Kepler 22b. For the planet to maintain adequate temperatures for liquid water, it needs to orbit closer to its star than Earth orbits the Sun. But here's where things get really interesting and potentially terrifying. If Kepler 22b rotates around its star the same way Earth rotates around the Sun, with regular rotation and a slightly tilted axis, temperatures could be relatively stable and similar to Earth's. But what if it's not like that? What if this planet's rotation axis is drastically tilted like Uranus, which literally rolls sideways as it orbits the Sun? In this scenario, Kepler 22b would experience extreme seasons that would last decades or even centuries. Imagine winters so harsh they would freeze entire oceans, followed by summers so intense that they would vaporize all the water from the surface. It would be a cycle of planetary life and death that would make survival of any complex life form nearly impossible. But there's an even more dramatic and scientifically plausible scenario: tidal locking. This happens when a planet orbits so close to its star that stellar gravity locks its rotation, causing the same side to always face the star. It's like the Moon relative to Earth. We always see the same lunar face. If Kepler 22b is tidally locked, we would literally have 2 worlds in one. The side facing the star would be a hell of unbearable heat, with temperatures that could melt metal. Constant water evaporation would create a runaway greenhouse effect, with massive storms, winds of hundreds of miles per hour, and a dense, toxic atmosphere. But the dark side, this is where our scientific imagination really takes off. Imagine an entire hemisphere in perpetual night, where temperatures would plummet to hundreds of degrees below zero. It would be a world of eternal ice, where even air could solidify and fall like snow. However, life has a surprising capacity to find ways to survive in extreme conditions. On the dark side of Kepler 22b, any life form would have to be extraordinarily adapted. Without sunlight, these creatures could develop bioluminescence, the ability to produce their own light through chemical reactions. Think of Earth's ocean depths, where we find jellyfish that glow like living lanterns, fish with luminous lures hanging from their heads, and even bacteria that create true gardens of light on the ocean floor. Now imagine these adaptations multiplied by an entire planet living in absolute darkness. These bioluminescent creatures could use their light in incredibly sophisticated ways to attract prey, confuse predators, communicate with others of their species, or even for navigation in a world without visual references. It would be like an alien light festival running 24 hours a day, 7 days a week for millions of years. Between these two extremes, the scalding hell and eternal ice, exists a fascinating zone called the Terminator Zone. This is the line of perpetual twilight where day meets night, a region where temperatures balance and conditions could be surprisingly habitable. In the Terminator Zone, we could find conditions most similar to Earth on the entire planet. Here, intense evaporation from the hot side and cooling from the cold side would create unique climate systems, constant rains, dense fogs, and perhaps even rivers and lakes formed by continuous condensation. It's possible that the first life forms on Kepler 22b originated exactly in this balance zone, gradually developing to colonize both the hot and cold sides of the planet. It would be evolution on 3 simultaneous fronts, an adaptation for each extreme region of the planet. But let's talk about another fundamental aspect that makes Kepler 22b truly unique: its atmosphere. Assuming it has an atmosphere similar to Earth's, with nitrogen, oxygen, and water vapor, surface temperatures in the Terminator Zone could reach a comfortable 72 degrees Fahrenheit, perfect for liquid water and potentially for life as we know it. However, if the atmosphere is completely absent, perhaps removed by solar winds over billions of years, temperatures could plummet to 18 degrees Fahrenheit, making most water frozen. On the other hand, if Kepler 22b's atmosphere resembles Venus's dense carbon dioxide-rich atmosphere, the surface could heat up to a scalding 860 degrees Fahrenheit, creating a runaway greenhouse effect across the entire planet. Now we come to the most shocking and challenging aspect of Kepler 22b, its brutal gravity. This planet is approximately 2.4 times larger than Earth in diameter, and scientists estimate it has up to 36 times more mass. This means its gravity would be about 6 times stronger than Earth's. To put this in perspective, if you weigh 154 pounds on Earth, you would weigh an incredible 924 pounds on Kepler 22b. Walking would be like constantly carrying 5 adult people on your back. Every step would be a Herculean effort, every movement a battle against relentless gravitational force. But extreme gravity wouldn't just affect humans. It would completely transform any fall into a potentially fatal experience. Free fall speed on Kepler 22b could reach more than 118 miles per hour. If you tripped and fell from a height of just 164 feet, equivalent to a 15-story building, you would hit the ground in less than a second, with devastating impact force. This extreme gravitational reality would fundamentally change how we think about architecture, transportation, and even sports on Kepler 22b. Buildings would have to be constructed with much more robust structures. Vehicles would need extraordinarily powerful engines, and physical activities would be completely redefined. Intense gravity would also drastically influence any life form that could evolve on the planet. Plants would necessarily be low and robust, with thick stems and deep root systems to anchor themselves firmly to the ground. Tall trees like those we know on Earth would be physically impossible,
They simply couldn't support their own weight. Animals would have to develop extraordinary adaptations. They would probably be small with wide, low bodies to better distribute weight. Many could have exoskeletons, like terrestrial crabs and insects, to provide extra structural support. These exoskeletons wouldn't just serve as protection against predators, but as vital support structures to prevent internal organs from being crushed by intense gravity. Imagine creatures that look like a mixture of turtles, crabs, and lizards, moving slowly but with great stability. They would have multiple legs to distribute weight, resistant shells for structural protection, and possibly specialized circulatory systems to pump blood against extreme gravity. But here's a fascinating question. What if Kepler 22b's oceans really exist? Scientists still can't completely confirm the presence of liquid water on the surface. If it's there, it would probably cover most of the planet, making dry land even scarcer than on Earth.
These alien oceans would be completely different worlds from what we know. High gravity would mean water pressure would increase much more rapidly with depth. What would be shallow water diving for us would be like descending into the oceanic abyss for Kepler 22b's inhabitants. Marine life in these oceans would be adapted to extreme pressures. From the surface, marine creatures could develop even more resistant shells, unique flotation systems, and perhaps even specialized propulsion capabilities to navigate in an environment where gravity pulls everything down with 6 times greater force. And the composition of this water remains a total mystery. It could be salt water, similar to our oceans, or it could contain completely different minerals and chemical compounds, creating an alien marine environment with unique chemical properties. A peculiar aspect of Kepler 22b is its shorter year. While Earth takes 365 days to complete an orbit around the Sun, Kepler 22b completes its journey in just 290 Earth days. This means if you lived there, you'd have more frequent birthdays, but it would also mean seasonal cycles, if they exist, would be faster and more intense. The distance that separates us from Kepler 22b is truly astronomical, 635 light-years, or approximately 3.7 quadrillion miles. To put this in perspective, if we could travel at the speed of light, which is physically impossible for objects with mass, it would still take us 635 years to get there. With our current technology, a trip to Kepler 22b would be practically infinite. Even the fastest spacecraft ever built would take millions of years to cover this distance. However, NASA scientists are exploring revolutionary propulsion concepts based on nuclear fusion and other advanced technologies. These theoretical propulsion systems could accelerate a spacecraft to 10% of light speed, an impressive 62 million miles per hour. Even with this fantastic speed, the journey would still take 6,350 years. It would be a journey that would span hundreds of human generations. But what if we could get there? What would the human experience be like on Kepler 22b? First, finding dry land would be an immense challenge, since oceans probably cover most of the surface. When we finally found land, every step would be a battle against gravity 6 times stronger. Living on Kepler 22b would require extremely advanced life support technology. Robotic exoskeletons would be essential to allow basic movement. Habitats would have to be built like underground bunkers to protect against extreme weather conditions and to provide structural support against intense gravity. Food production would be revolutionized. Traditional agriculture would be impossible. Terrestrial plants simply couldn't grow in extreme gravity. We would have to develop genetically modified crops or specialized hydroponic growing systems. But perhaps the most intriguing aspect is speculating about what types of life could naturally evolve on Kepler 22b. Given the high gravity, life forms would probably be small but extremely resistant. They would have body structures optimized for energy efficiency in an environment where every movement consumes 6 times more energy.
If intelligent life exists on Kepler 22b, it would be fundamentally different from us. Their architecture would be horizontal instead of vertical, their transportation would be designed for extreme gravity, and their understanding of physics would be based on a gravitational reality completely different from ours.
These intelligent creatures could have developed technologies we can't even imagine, perhaps methods of gravitational manipulation, ultra-resistant materials, or energy systems based on the planet's own gravitational pressure. The search for signs of life on Kepler 22b continues to be one of modern astronomy's priorities. Next-generation space telescopes like the James Webb are being used to analyze the atmospheres of distant exoplanets, looking for chemical signatures that could indicate the presence of life. If we can detect oxygen, water vapor, methane, or other gases associated with life in Kepler 22b's atmosphere, it would be one of the greatest discoveries in human history. It would prove we're not alone in the universe, and that life can thrive in conditions very different from Earth's. Kepler 22b represents both a promise and a cosmic enigma. It's a world that has all the basic ingredients for life: a stable star, an orbit in the habitable zone, and possibly oceans of liquid water. But its extreme conditions of gravity, rotation, and climate create challenges that defy our understanding of what makes a world truly habitable. This planet forces us to rethink our definitions of habitability and life. Perhaps life is much more resilient and adaptable than we imagine. Perhaps there are life forms thriving in conditions we would consider impossible. Kepler 22b is a reminder that the universe is full of worlds that challenge our imagination and expand our horizons about the possibilities of cosmic life. As we continue our search for extraterrestrial life, Kepler 22b remains one of the most fascinating candidates, a world that could harbor completely alien life forms adapted to conditions that seem straight out of science fiction, but are perfectly real 635 light-years away. And you, what do you think? Can you imagine what life would be like evolving in such extreme conditions? Do you believe we could one day develop technology to visit worlds like Kepler 22b? Leave your opinion in the comments. I love reading your theories and speculations about these mysterious worlds. If this video sparked your curiosity about the mysteries of the universe, don't forget to like and subscribe to the channel so you don't miss any of our cosmic explorations. Turn on notifications because we always have new content about the most fascinating secrets of the cosmos. Click on the video that's appearing on the screen now. Thank you for embarking on this cosmic journey with me. Until the next exploration through the infinite mysteries of the universe.